Hi, economics major and statistician Tom. As you know, our company, Phony Phones, sells cell phones. I have data on all 50,000 phones we sold last year.
What would you like me to do? We want to compare the number of quality problems we had last year with our competitor, Xylophones, who sold 90,000 phones. Remember, phones can have more than one problem. Okay, I can do this. I guess I need to find some measure central tendency. I will calculate the average, which is the sum of the number of quality issues divided by the number of phones sold. Hi Sally, I need help. Our cell phones have much higher average quality problems than our competitors. 9.3 to 2.1. Are our phones really that bad, or am I doing something wrong?
Hi Tom. I think I know what the problem is. You measure the mean, which is a great measure of central tendency, but it tends to have some problems with outliers. Here's why. Suppose we meet up with 8 of our economics graduates at a bar tonight and we are the only ones there. Since we all earn $60,000 per year, our average salary is $60,000.
That makes sense.
Suppose Tiger Woods comes into the bar. You know he was an economics major. His salary last year according to Forbes was $78.1 million.
Wow. I guess that will raise the average.
If we recalculate the average salary, it is now $7,154,545.45. So this outlier can have a major influence on the average. We might want to look at the median instead.
Yes, the median is the point that divides the distribution in half. This means that half of the observations lie above the median and half lie below.
Right, the median salary before Tiger walked in was $60,000. After Tiger walks in, the median is still $60,000. Even if Mick Jagger walks in, the median will still remain at $60,000.
Oh yes, Mick Jagger was an economics major also.
If there are no outliers, the mean and the median are likely to have similar values. Perhaps we should look at a histogram that shows how quality...
Okay, let's do this. Let's have Professor Goman describe it on screen for us.
Hello, Professor Goman. Can you show us how to make a histogram?
Okay, we have Tom's phone quality problem data from Phony Phones. First, let's find the mean. And so the first column here shows us the ID of the people who own the phones. Second column shows the quality of the phones. And the third column shows the manufacturing site. So we're interested in the mean of the quality problems. So let's go to column D here and type in the word mean. All right, so to do the mean, go to cell D2. We just do equal average in parentheses, and then click on the 2 in column B2 and hit Control and Shift and push the down arrow, and that will take you to the end of that column, and then we can hit return, and that should give us the average, and it did. And the average is 9.3, and that's what Tom had calculated. Sally suggested that Tom calculate the median, so let's calculate that in the column E. So we type in median, and then to calculate the median we do equal median paren, left paren, and then click on column or cell B2, hit Control Shift and the down arrow key. That will take us to the bottom, and hit return, and now we see that the median is 1. And so it does look like that there's some problem with outliers, since the median is so low and yet the mean is so high. And so a good way to find out if there's outliers would be to look at a histogram. And so to do a histogram, we're going to use what is called a pivot table. To use the pivot table, we need to select our data. So go to cell A1, do Control Shift, push the down arrow, and then push the right arrow, and that will cover all of our data. We just want to go from columns A, B, and C, so we do that, and then we hit Insert, Pivot Table, and let's insert this on our worksheet here, and we'll put it on G5 and say OK. And then what it does is it tells us where the pivot table will be, and then over here it gives us the information that we're interested in. And we're interested in quality problems. And so we want to put quality problems as our row label and also as the values we're interested in. Now here it's actually adding up the number of values, and what we really want is a count. And so if we click on this value over here and change the value field setting from sum to count, then it will count the number of times we had one error quality problem, two quality problems, and so forth. And so we click that OK, and now we get our distribution of quality problems. We had 0 quality problems for 12,500 phones. Notice the number dropped off quite dramatically, and then it started going up very high numbers of 20, 30, and so forth. Okay, so this has given us our frequency distribution. And now what we want to do is find a histogram that will graph out this distribution. And so to do that, we go up here on options, over here to pivot chart, and we're going to pick a bar graph. And so we're going to use clustered column. We click OK, and it gives us our distribution here. And let's move this over a little bit. Move the table over some. This distribution looks quite dramatic. We have very few errors, and then we go out and we have lots of large errors. And so we might want to examine what's the reason for these large errors. So if we go back to our data, and so we'll go hit Control Home, that takes us back to the top of the page here. Notice we also have manufacturing site. And so maybe we can use this pivot table to see if there's anything going on with manufacturing sites. And so let's insert a new pivot table. So insert pivot table. We've got the same data. We actually only want to go to column C, not column E. So make that column C, OK. And it has put this pivot table in a new sheet here. But let's look at manufacturing site as our row label. And let's look at quality problems for the values we're interested in. And in this time, we're actually interested in the sum of quality problems. For example, if Ohio had no quality problems or they were all zeros, we would add that up, and maybe they had a few ones and so forth. And if we look at the sum of quality problems, Ohio, North Carolina, Kentucky, and Indiana only had 10,875 quality problems, whereas Colorado seems to have a quite dramatic increase in the number of quality problems. And so this information is useful to us because it tells us that the problem is at the Colorado plant, and we need to go look at the Colorado plant. If we throw out the Colorado plant, it looks like we don't have very many problems at all with our phones, and we're doing quite a good job relative to our competitors. And so it's very useful to look at your data. Obviously, you want to look at your measures of central tendency, the mean and the median. And if they're very different from each other, you would also want to look at some sort of histogram or frequency distribution, as we've done here, and try to determine what's going on. And since we had lots of outliers, we needed to analyze where were these outliers coming from. And when we looked at where the manufacturing sites, we saw that the manufacturing problems were all occurring in Colorado. So something's going on in the Colorado plant, and we need to talk to the manager there. So this sums up our measures of central tendency and how to use a pivot table and histograms to examine our data.